So this is 2.6, and this is rational functions. And y'all listen, we're recording this class, and so I'm going to break it down very basic. I'm not going to do a bunch of fluff and stuff. You'll be fine with it, but it'll help the other kids that maybe want to go back and watch the video. Okay? So rational functions. So first of all, let me explain a little bit about what a rational function is. You took a test over the basic functions, what their graphs, domains, and ranges were, right? Okay. So you should kind of remember what that rational function looks like, but I'm going to throw him up here for just a second. All right. So f of x is equal to 1 over x. Now, I'm just going to, real quick, we're going to do a little t-chart here. We should know what it looks like. I'm going to do this t-chart on the left-hand side. So I'm going to start out here. I'm going to pick -4. 1 over -4 is -1/4, right? So at -4, it's -1/4. What if I put -10 in it? What would it be? Are y'all not going to talk to me? If I put -10 in it, what would it be? -1/10. What if I put -100 in it? -1/100, right? What's it doing? What's this thing doing? No. Thank you, Amon. Yeah, what's the curve doing? What's the graph doing? He's getting closer and closer to what? The x-axis, okay? So we know what he's doing out here. He's getting closer and closer. Is he ever going to get to 0? No. Why can this fraction not get to 0? That's not right. That is true, but that's not why this can't be 0. Why can this... That's exactly right. Y'all, the only way to make a fraction 0 is to have a 0 on the top, right? 0 over anything is what? 0. All right, so you can't make this equal 0. I can get very, very close, but I can't get there. All right, so let's try -2. -2 is going to be -1/2. What's he doing? He's pulling away from it a little bit. All right, what about -1? Yeah, 1 over -1 is -1. All right, so it just kind of pulls off of it just a little bit. Now, what about 0? Can I put 0 in for x? Why? Can't have a 0 in the denominator. That's undefined. What's it called? What does it make? An asymptote. It makes an asymptote. At wherever that 0 of that denominator is, that's going to make an asymptote. So I got an asymptote right here. It's a vertical asymptote. What's the equation of it? Very good. X equals 0. It's a vertical line. Remember how the X looks like 4 V's all stuck together? So it's X equals 0. So let's look in between 0 and -1. What if I put a number like -1/2 in there? Y'all, when you put 1 over a fraction, what does it do to that fraction? It just flips it. It makes its reciprocal. So what's 1 over -1/2? -2. So at -1/2, it's -2. What's it going to be at -1/4? -4. So he's going to come down here like this. All right, so now what's he doing? He's approaching what? The y-axis. Okay, so that's what my curve looks like. Now he's going to do the same thing over here. Okay, he's going to do the same thing over here. If I start at 1/4, that's 1 over 1/4. That's going to be 4. So at a 1/4, it's all the way up at 4. At a 1/2, where is it? At 2. Very good. So at a 1/2, he's gone to 2. At 1, he's 1 over 1. That is 1. At 2, he's 1 over 2. Well, that's a 1/2. You can see he's doing the same thing. And then at 4, he's a 4. So he's approaching this y-axis right here, and he's approaching this x-axis right here. Okay? Now, notice this. Look, this is just a little cheat for you. If you put that on a calculator, is it going to look like it goes on forever and ever? No, it's not. And is it going to look like it's approaching the X and Y axis? No. He just does like this. On the calculator, it looks kind of like this. Okay? And the reason is just because he just gets so close to it that it just, essentially the pixels can't really say that he's not on top of it, so it looks like he is. So you have to know what it really looks like. All right. What's this asymptote right here? Because obviously it has an asymptote right there. Y equals 0. Now, what is the definition of an asymptote? Okay, an asymptote is a line your graph approaches. When I taught regular algebra and we had vocabulary tests, asymptote was one of our words on our vocabulary, and more than half the class would say a graph your line approaches. I'm like, no, that's not what it is. Okay, you flip those two words, but it's really important that you say it that way. What?
I'm sorry, I didn't mean to interrupt, but negative plus and display bar is really important. Not like crazy.
Oh, well, yeah, when we finish. Okay? All right. So now I want you to do this. All right? I want you to take out one clean sheet of paper. Oh, let's do this real quick. What's the domain of this function in interval notation? Negative infinity. Very good. Very good. Negative infinity to 0, exclusive, union, 0, exclusive to positive infinity. What about the range? Yeah, he's going to be the same thing. He's going from negative infinity, can't hit 0, okay? This y right here can never be 0. We talked about that. So negative infinity to 0, union, 0 to positive infinity. Okay, so now I want you to take out one clean sheet of paper, and every time you graph, this is what you're going to have to list. Now, y'all, it's going to kind of feel like maybe we're back in trig again. Remember in trig when we graphed sine and cosine functions and you had to find the amplitude, the period, the horizontal shift, the vertical shift, all that kind of stuff? This is the same thing, but you're not finding that stuff, but you are finding a list of things, okay? But in Algebra 2, I let you use this list on the test. In PreCal, you will not be able to use the list, okay? So you're going to have to practice them enough. I'm giving you 6 problems to practice on your worksheet, okay? So I'm going to require that you practice 6. If you need more practice than that, then, you can pull some problems out of your book. All right, so here's the things we're going to find. The domain, Zach. Cane. Come on, Zach. All right, domain, range. Domain and range. Okay, what else? Vertical asymptote. What? Was he asleep? Yes, he was. Vertical asymptote. Horizontal asymptote. Leave me about 3 or 4 lines right here. Yes. This needs to be on one separate sheet of paper. This is like your giant cheat sheet. Okay? This is your giant cheat sheet. Every time you graph something, you're going to look at this. Okay? Except when you're taking a test. Yes, we did. Of course we did. All right, horizontal asymptote. So leave me about 3 or 4 lines. And then we'll have to do a slant asymptote. And then you have to do a point of discontinuity. And then you have to do an x-intercept and a y-intercept. Okay, so here's what we're going to do, guys. The other kids, we went and started to kind of work a problem and stuff like that. We're just going to write all this stuff down, all right? So, domain. Y'all, your domain is going to be any x except you have to exclude the x's that make zeros in the denominator, okay? So, you're going to exclude the zeros of the denominator. Now, one of the reasons I really liked the hour-and-a-half class is because we could write all this stuff down and work a problem, and you would make a lot more connections with it. But we'll work problems tomorrow, okay? The range, people, you're just going to look at your graph. You're going to graph it, and then look at the graph and write your range down. You'll start to make some connections between your graph and some other things that you have written up here, but you'll make them. It'll be good. Vertical asymptote. What did we discover over here that made a vertical asymptote? Yeah. Look. Yes. Zeros of the denominator. Okay? So a vertical asymptote, they are the zeros of the denominator. Have you already found them? You found them right up here, people, and you excluded them in the domain, so I don't have to find them again. I just look up there and go, oh, there they are. Zeros of the denominator. Now, I will tell you this. Why do I keep putting an I right there? I don't know what I'm doing. Okay, you have to write x equals. You cannot just write a number. It's not a number, it's a line. Okay, horizontal asymptotes. These are probably one of the most difficult ones. All right, so before I write what they are over here, I want to give you a little legend of the abbreviations I'm going to use, okay? Guess why you need what? Yeah, because we got to, all right, so the first abbreviation I'm going to use is the DD. It stands for the degree of the denominator. And DN stands for degree of the numerator. LCD stands for the leading coefficient of the denominator. LCN stands for the leading coefficient of the numerator. Alright, so those are going to do. So I'm talking about degrees of the numerator and degrees of the denominator. How do I find the degree of something? Highest exponent. So all you're doing, people, is looking at the top of the fraction, what's the highest exponent? Looking at the bottom of the fraction, what's the highest exponent? Okay? Now these two numbers, either the top's going to be bigger than the bottom, he's going to be smaller than the bottom, or he's going to be equal to the bottom. Those are the only three choices, right? Okay, so let's do this. Let's say, oh, there he is. Let's say the degree of the denominator is greater than the degree of the numerator. If that is the case, then my asymptote is y equals 0. Or the degree of the denominator could be equal to the degree of the numerator. And in that case, my asymptote is y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. The only other option is if the degree of the denominator is less than the degree of the numerator, and in which case it will have no horizontal asymptote. Okay, so let me tell you a little story how to remember this really easy. Do y'all remember this last year? We talked about a vase. Okay? We talked about a vase. We said it was a really expensive vase. We were going to call it a vase. All right? And we're going to put it on the table in the living room. All right? If the bottom, that's the degree of the denominator, is bigger than the top, my vase would look something like this, right? Is that good? Yeah. My kids could run by that and probably not knock it over. All right? So, he's just normal. That's just like the parent function. That's normal. Y equals 0. Now, what if the degree on bottom and the degree on top are the same? Well, that's kind of like a cylinder. He's the same on the top and the same on the bottom, so that's what we call equal representation. He's equal on the top. You got the top screaming, "Hey, hey, I get to be represented," and the bottom says, "I do too." So it's the leading coefficient of the top over the leading coefficient of the bottom. So equal representation. All right. Now, what about this one? This one says the bottom's less than the top. Oh, my. This is a very dangerous situation. Okay? A vase like this, my kids just walk by it and break it. Okay? So this is bad, 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 bad. Michael Jackson bad. Okay? And so it has none. There is no asymptote on that one. All right? So this is an easy way to remember. If the bottom's bigger than the top, it's just normal, y equals 0. If they're both the same, it's equal representation, so you'll do the leading coefficient on the top over the leading coefficient on the bottom. If that thing's top heavy, he's bad. He doesn't have one. Okay? We're going to come back to these two. Let's do these two down here. An x-intercept. Anybody know how to find an x-intercept? Yeah. You make y equal to 0. Plug in 0 for y. And then you solve for x. Okay? I'll let you use this when you did your test. Okay? Because it's a lot, and we always do it at the end of the year, and it's just a lot. So, y-intercept. How do you find a y-intercept? Yeah, you make x equal to 0, and you solve for y. Thank you. Okay, so these are all the things that we're going to do. We're going to talk about slant asymptotes and points of discontinuity, not tomorrow, but the next day, so Thursday, all right? But they'll be pretty easy. So that's all we're going to do today. Tomorrow we'll start working some problems.